So here in this part we discuss the derivatives formula. So first of all, the derivatives can be done in two ways in our syllabus. This is the first principle, or by definition. So first principle or definition is actually the formula maker. Okay, so here we use a formula like f dash x, which is limit h tends to 0 fx plus h minus fx whole divided by h. So this is the formula for first principle. Okay, and the next method is by formula. Okay, so two methods are there. This is number one, first principle, and number two is by formula. So I am going to write down the formula which are commonly used in class 11 over here. First principle, this is the only formula that we will do some sums and you will get to know this. So now the formula, by formula, the formula we see few algebraic formula are also there and few trigo formula, log formula, these are there in our syllabus. Now first thing is that ddx of any constant, okay, that is 0, because constant does not change with time, it becomes the same, it's constant, there is no change. And derivatives, as I told, that derivatives is some rate, okay, it's determination of some rate. So rate of change of c with respect to x will be 0. Okay, now second is ddx of x, that is 1. See, the rate of the numerator and the denominator are same, so it's 1. And ddx of x to the power n, that is nx n minus 1. Number 4, ddx of log x, you can say, that is 1 by x. Number 5, ddx of e to the power x, that is e to the power x only. Number 6, ddx of a to the power x. A to the power x means where a is some constant. So a to the power x, it will be a to the power x and log a. All these logs, you know, over here has a base e in calculus. So we get to see, so these are the few algebraic limits which we get, and the trigo limits are as follows below. Number 7, ddx of sin x, which is cos x. Ddx of cos x, which is minus sin x. Okay. Now ddx of tan x, which is sec square x. Ddx of cot x. Okay, this is minus cosec square x. A minus comes. Ddx of sec x. This is sec x tan x. And the last one, for the time being, I write ddx of. So these are there in our syllabus up to number 12. cosec x. This is minus cosec x cot x multiplication. Okay. So I will tell you a short trick to remember all this. Just see, few of the differentiation are getting negative. Say this one cos x, then again this one, then again the last one number 12. So these are negative. Minus sin x this one minus cos x square x, and this one minus cosec x cot x. So a very unscientific tip would be some kind of, when you see a c in front, cos x or cot x, every time c in front you can remember like this initially, that your derivative will be, differentiation will be negative. Okay. Now a few things I'll write over here, that is, if I get a constant associated with x, okay, then it will be displayed outside. So what do I mean? Say this formula number 4, instead of this, if I write ddx of log mx, okay, ddx of log mx, if I write, then it will be 1 by mx, only m will be displayed outside because m is there with the x. So eventually you get, so first of all it will be 1 by mx only, whatever log function is there, 1 by reciprocal, so that thing will come, so it will become 1 by x. The answer is this. Now if you get this one, say anything, like it's applicable to anything, e to the power mx, okay, e to the power mx is there, so you write the same thing over here at first, that is e to the power mx only. In front you just write m, so that is m is producted with e to the power mx. Here also the same thing, if you write ddx of a to the power mx, this will become a to the power mx into log a, whatever I wrote over here, base e, but m will be written outside. So m, if it is multiplied with x or the coefficient of x is m, it will be written outside. For this also the same thing, ddx of, if you get, so now I'll take a value to show you, that will be more realistic. If it is sin 3x, okay, so this will be cos 3x only with a 3 outside. Here the value of m is 3, okay, you see the value of m over here is 3. So anything, any of all these formula are valid with respect, say tan x, if I write ddx of tan 2x, okay, ddx of tan 2x, if I write this, it will be sec square 2x, but a 2 will be written outside. So this is the thing. Now anything, say this formula, ddx of, if I write sec of 7x, okay, so it will be sec of 7x tan of 7x, sec x tan x. This thing will be written as per the formula, and then 7 will come outside because 7 is the value of m, okay. So it's like this, generalized, you can use like this, okay. So these are the formula for differentiation. Thank you.